All right, we're starting week 8. I'm sorry, unit 8, day 6, not week. I will mention that I tried to be cheap and save ink. So when I printed this, I used low quality, and well, it's kind of hard to read some of this stuff. But if you look at your notes, it should be pretty clear, and hopefully it's not too bad. But so starting off, this is day 6A. Notes, we're going to talk about geometric series. There's actually two different kinds. There's a finite, which is what the front side of the notes is going to be about, and there's an infinite geometric series. So first off, a geometric series, the series just means that it's a sum, okay, a sum of a geometric sequence. And remember, geometric just means you're multiplying by the same number.
Here's what I found.
Sorry, my watch thought I was talking to it. You're multiplying by the same number to get the next term every time. So you're tripling it every time, or you're multiplying by a third or by a fourth or whatever. Just like with arithmetic, there is a shortcut for adding them up. So as long as it is a finite series, meaning there's a first term and a last term, so there's a set number of terms, then the sum of the number of terms, however many it is going to be a sub 1 times, and then 1 minus the common ratio to the n power divided by 1 minus the common ratio. And I put those in parentheses because when you put them in the calculator, you want those in parentheses. If r is a negative, make sure you put that in parentheses also. You want that in parentheses because it all depends. If it's a negative to an odd power, then it's going to be a minus, so minus and negative is plus. But if it's negative to an even power, it's going to be positive, so you're actually going to subtract that. So we do want to keep our order of operations correct here. Okay. And again, down here, where a sub 1 is the first term, r is the common ratio, and n is the number of terms in the sequence. So that's what all these letters mean. So let's practice this. If you remember, this symbol means add them all up. So we want to add up all the terms. In which terms? The first 8 terms, so from 1 to 8. And here's our stuff. So remember this, and think back to your exponential unit, at least that helps me, is that's your initial value. So that's your a sub 1, and then this is your common ratio, okay, when you're plugging stuff in. In fact, down here I've got it written already. The geometric explicit formula is a sub 1 r to the n minus 1. So a sub 1 r to the n minus 1. We need that information. So if I'm trying to add these up, the sum of the first 8 terms, so n is 8, is going to equal a sub 1, which is 2, 1 minus 3 to the 8th power, divided by 1 minus 3. Okay, this one's, it kind of takes a lot longer to explain why this formula works. This is one of those where I say just trust me that it works. You might want to pause here and practice putting it in the calculator, just make sure you can do it right. I'm going to go ahead and write down the answer to save time. So it's 6,560. Let's see the next one. Okay, so here, again, that's a sub 1. There's my r, and it's 10 terms, so from 1 to 10. So the sum of the first 10 terms would be a sub 1, and a sub 1, 1 minus, and then my r is 0.5 to the 10th power, all over 1 minus 0.5. Okay, and I should be putting this in parentheses. If you want to put this all in the calculator all at once, when you divide, make sure you put the denominator in parentheses. Okay, so again, you may want to pause right now, try it, and then see if you get 4092. Let's see, down here, so using the geometric series formula, so we're going to give you the numbers themselves. So instead of giving it to you in summation notation, like what up here, we're just going to give you the series, or the sequence, and you got to add it up yourself. It is helpful to find it in summation notation first, and then plug everything into the formula. So on this one, it looks like I'm adding up, and it goes up to s sub 10, or we want to find the sum of the first 10, so that's going to be n equals 1 to 10. And now I'm trying to figure out what is the formula here. Well, a sub 1 is 162, is just what is r? And if you remember, the fastest way to find r is take any term divided by its previous term. Whoops, previous term. So this one, if I took 81 divided by 162, I'm going to get my r, which in this case is 0.5. Okay, so when I go to find the sum of the first 10, it's a sub 1 minus 0.5 to the 10th power, all over 1 minus 0.5. Okay, so stop here and put that in the calculator. Now I got a decimal number. If you don't like that, you can actually, I don't know what numbers I have in here still, but for instance, this number here, if I want that as a fraction, remember you can push math and go, and the first option means change it back to a fraction. Oh, this one doesn't do it. But if you ever want to change any number, like say I have a 2 divided by 3, and it says 0.6 repeating, maybe I forgot, and I didn't see that this is 2 divided by 3, I can go to math and go to fraction and put it back, and it'd be 2/3. So if Math Excel keeps rejecting your number, maybe put it in as a fraction. That might give you the answer more often. So when I did that with this, it was 82863 over 256. Okay. So now part B, again, I'm adding up from the first term to the 8th term. The a sub 1 is -2, and now I'm trying to find out what is r. Remember, r is take any term divided by the previous term. So 10 divided by -2 would be a -5. Okay, so here's one where we got a negative r. We got to be careful putting this in the formula. So the sum of the first 8 would be a sub 1 times 1 minus -5, but I got to take that to the 8th power first. A negative to the 8th power is actually going to be a positive, so it's going to be 1 minus whatever this number is. If it's an odd power, some people mess up, they switch to the signs right now. Don't do that. Take it to the 8th power first, and then worry about the signs. And then on bottom is 1 minus -5. Since there's no power here, I can just switch that to a plus. So there will be a 6 on bottom. So put it in the calculator, I get 130,208. Okay. Again, anytime if I'm going too fast, pause it, go back, look at it. If you need to, note it, and then send me an email, ask me to explain it in more detail, and I can definitely do that. Okay, so the sum of an infinite. So infinite means it just goes on forever. Now, if the numbers are growing, okay, so for example right here, first one 5, then 15, then 45, and so on, that is going to go on forever. Like basically, it's just infinity is going to be the answer. So you can't find the sum of that. But if it is getting smaller and smaller, eventually the number is so small that it's not actually adding anything to the value of the series. So what we're looking at here, one way to tell you that is the r. Okay, and it says the absolute value of r is less than 1. Kind of made a different way of saying that is it's between -1 and 1. Okay, so if the r value, basically if it's a decimal less than 1, it can be positive or negative, then it will what we call converge, which means the numbers get smaller and smaller, and eventually the numbers are so small they're not changing the sum at all. They're just such a tiny amount. Okay, so if it is convergent, we call it, if it converges, then the sum, this is probably the easiest formula of all the formulas we have to know. Well, I say you have to know, you just have to know how to use it, because we'll provide you with a formula sheet, is a sub 1 divided by 1 minus r. Okay, and so the two things you need to know is the first term and the common ratio. If you know those two, you can find it. Okay, so a divergent series, the sum is basically infinity, so there's no answer. We don't answer this one. So if the r is greater than 1, or if the r is less than -1, you can't find the sum. Okay, so on this one, the common ratio, again, take any term divided by the previous, so 15 divided by 5 would be 3. It is greater than 1. Its absolute value is not less than 1, so it is divergent, which means it goes on forever, so there is no sum. Okay, no answer to this one. or infinity, but we don't really put an answer down. Now, a convergent series, again, this is one that converges. The numbers are getting smaller every time, so eventually you're not adding enough to make a difference. Okay, so this one will have a sum, so it has a sum. So what I'm going to check here, take any term divided by its previous. So 10 divided by 50 is 1/5. Okay, so this one will have a sum. Okay, so this is an example of one that will. This is one that does not have a sum. So let's go down and try to find some here. So these say, does the series converge or diverge? So converge means basically the numbers will approach 0. Diverge means they approach something besides 0, like they might keep increasing more and more and more. And it's not necessarily 0 when I say converge, it could be approaching 1 or something like that, but it's approaching a number. As these numbers go on, you're getting closer and closer to a single number versus getting closer and closer to infinity. Okay, so if it converges, find the sum, otherwise don't worry about it. So on this one, the numbers are getting bigger and bigger and bigger, and I could take any term divided by the previous. That means that r is too big. Okay, it's greater than 1. So this one diverges. The next one, take any term divided by its previous. So r is going to equal 162 divided by 324. That equals 0.5, so it does converge. Again, the only two things I need to know is the first term and the common ratio. If I know those two things, I can find the sum of that infinite series. So the sum, as I go to infinity, because I'm going to add up, it just keeps going on forever. Well, eventually, since it's shrinking, it's such small increments, it's not going to do anything. Is 324 divided by 1 minus 0.5. Okay, so type that into the calculator. Again, put this in parentheses when you put it in the calculator. It'd be 648. And if you wanted to check this, start adding the numbers up, and after about 50, maybe even after like 20, when you add the 21st term, the number's not really changing. It's just a number slightly less than 648, so that just means as you get towards the end, it's going to equal 648. This guy here, yeah, I'm not sure. This one's kind of bouncing back and forth. One negative, positive, negative, positive. So let's just check the r. Because if the r, again up here, if the absolute value of it is less than 1, we can do it. If it's greater than 1, then I can't do it. Or if it's equal to 1, I can't do it. So take any term divided by its previous term, and that's negative 2. That it needs to be between negative 1 and 1. So this one is divergent. So it diverges. Okay. Now determine if an infinite series has a sum using summation notation. This is almost an easier question because up here I had to find the r myself. Here they're screaming it at us. Remember, this number is the r. So these will tell me if it's convergent or divergent. Okay, so let's just go through and find that out first. So 5, okay, that's greater than 1, divergent. So it diverges. 2/3, that's less than 1. So it's between negative 1 and 1, so that's convergent. So it converges. 5 halves. Okay, you think fraction, that might trick a few people. That's more than 1, so it's divergent. Diverges. 1/5, less than 1, converges. And then negative 1/3. Okay, it notes negative. It's between negative 1 and 1, so this one converges. Okay, so these guys we have nothing else to do with because they're divergent. I can't do anything with it, so I can't add those up. But the convergent ones, I need the sum. Again, these all say to infinity. Whoops. So to infinity is a sub 1. Remember that number out front is your a sub 1. 1 minus r. Okay, if you're going to put it in the calculator, make sure you put it in parentheses. You get 18. Over here, sum of the first, or the infinite terms, there is no number out front. So remember, no number out front means a 1. So a sub 1 is 1. 1 minus 1/5. Okay, put that in the calculator. And that's 1.25. Okay. And then this last one, the sum of the infinite series, first term is 7. 1 minus the common ratio, it's a negative, so it's actually going to be a plus. So 7 divided by 1 1/3 is 5.25. Okay? So, let's keep moving on. We got some word problems here we're going to do. Just 3 word problems. So you got to kind of set it up and figure out, is it infinite or is it finite? Okay? So the weight at the end of a pendulum swings through an arc of 30 inches on the first swing. So you got this weight. Check my drawing here. It's swinging back and forth, and the first swing, that arc is 30 inches. After that, each successive swing is 25% less than the length of the previous swing. What's the total distance it traveled? Okay, so first off, this is geometric because we're going to be multiplying. We're going to lose 25%, which means we're going to keep 75%. And it is, it's approaching 0 as it goes along. So, I mean, technically infinite number of swings, but it does stop. But we don't know when it's going to stop. So we say the first swing all the way up to whatever swing it is that ends up making it stop. The first swing is 30, so a sub 1 is 30. And what's my ratio? My common ratio, I lose, so it's 5% less. That means it's 75% left. Okay, so there's my summation notation. A sub 1 and r is all I really need. So the sum of these infinite swings is going to equal 30 divided by 1 minus the common ratio, 0.75. Okay, so put that in parentheses, put it in the calculator, and it's 120. Okay, so it's 120 total inches that pendulum will travel. Suppose your business made a profit of $3,400 at the end of its first year. Yikes. Must be a coronavirus year. If the profit is expected to increase at a rate of 15% per year, find the total profit over the first 10 years. So this is geometric because it's going to be multiplied by the same common ratio every time, but it's finite because it's only for 10 years. So summation notation would be from 1 to 10. My initial value is 3,400. Now my common ratio, don't make the mistake of putting 0.15 in there, because I'm not increasing, I'm not getting 50% left, it's increasing by 15%, so it's 1.15. Okay, so that means since this is a finite, it's the first formula we went through. Let me put it up here for you if you can see it. It's this guy right here. So you know the difference in your two formulas, and you'll check back on your notes anytime in your homework. So it's going to be a sub 1, 3,400, 1 minus 1.15 to the 10th power over 1 minus 1.15. You can put that in parentheses when you put it in the calculator. Okay, and you get, so the first 10 years, the total profit would be $69,032.64. Okay. Letter C. You're given the choice of how you would like to receive an allowance over the next 52 weeks. Okay. So the first way would be I give you $1,200 per week. It's a good deal. Or the second option is I'm going to give you a penny the first week, and then 4 cents the next week, and then 7 cents the third week, and so on until the 52nd week. Which option would be your choice and why? Okay, so think about this one. Okay, so let's figure it out. So option 1, this is not a sequence because it's not changing. It says $1,200 every week for 52 weeks. So option 1 would be, 1,200 times 52, and that's going to equal 62,400. Okay. Now, I'm looking at this guy. So option number 2, we're sort of tricking you a little bit. Okay. So the pattern is, am I multiplying by the same thing every time, or am I adding something every time? Okay. My son is actually over my shoulder right now, and he whispered to me that you're adding 3 every time. So this is arithmetic. This is an arithmetic sequence. which doesn't grow quite as fast as you might like. So I'm betting option 1 is probably a little better. So with an arithmetic sequence, let's just do summation notation first off. Remember, arithmetic, the a sub n, so kind of a little bit of review here, is your initial value, a sub 1, so a sub 1, plus your common difference, which in this case would be 3 cents, n minus 1. Okay, if I do some simplifying here, just it'll be 0.01 plus 0.03 n minus 0.03. So that would be a negative 0.02 plus 0.03 n. Okay, now, if you remember your formula here, the sum of those 52 is going to be, it's the first term plus the last term times the number of pairs you have. So if there's 52 terms divided by 2, there's 26 pairs of these. The first term is 0.01, and then the last term is what you'd get if you plugged in 52 into here. So 52 times 0.03 and then subtract 2, it's actually $1.54. So that means the last week you made $1.54. So my guess is we're nowhere near this guy right here. So if you put all this in a calculator, it's $66.04. So if you chose option 2, we tricked you a little bit. Now if this was a geometric sequence, I'm pretty sure option 2 would work if it was following a multiplication pattern. This is an addition pattern. So option 1 was a much better choice on this one. So again, just like last week, if you have questions, email me and I'll try to make a video and send it back to you. I'm not sure, I'm trying to find time to do Zoom, but I'm not sure I'm going to have time to do Zoom. But yeah, it always works. Just send me a quick email. I can make a 1 or 2 minute video explaining it. I can send it back to you, and that kind of works better, you know, for me with my schedule.